Ben's got this?
Not all of it. I have a few.
Okay. So let's start. So boiling is hot liquid evaporates, creating water vapor. It's a forced process. That's something I want to add to this. It's a forced process. It's something that you make happen. So it's something you force to happen. It doesn't happen. Boiling is not necessarily something that happens naturally. Evaporation happens naturally. Boiling is something you make happen. Like you put it on the stove and you turn the burner on. So that again is a forced process because there's heat from the earth coming into that and forcing it to raise its temperature. Yeah. Or something forces the pressure to be different or something like that. Yeah. Okay, so it's a forced process. So how is boiling similar or different from evaporation?
Still a phase change.
So it's still a phase change. So it's even the same phase change. The difference is this forced idea. So evaporation is natural. And boiling isn't. So evaporation is natural, boiling isn't. Yeah.
They're also both cooling.
Yeah, they both are cooling processes. Now, I know that sounds weird on boiling. Correct. It's trying to cool down. The reason why it's boiling is because it's getting rid of the high energy stuff so it can have lower energy stuff left over. When you're boiling a pot of water, though, you keep heating up the water. So even as it's cooling, you're heating it up again. That's why you have to keep the burner on when it's boiling. You can't get it boiling and then turn the burner off and it'll keep boiling. It'll cool off. That's why you have to keep the burner on. Okay? So they're both cooling process. It's the same phase change. But evaporation is natural and boiling is not. So how can it be a cooling process if it happens at high temperatures? We kind of said that. So it's trying to cool, but if you add heat to continue the process, it can't. Right? So if you're forcing it to keep boiling, it can't cool off. But if you stop forcing it, then it'll eventually cool off through the process. There's a fun demo. I haven't been able to recreate it because I don't have a good enough suction chamber and I don't have a good enough pump. But you can actually boil something to freezing. So there's lots of ways to boil things. You don't have to add heat to boil something. And you can actually boil water so much that it freezes. And that's because it's a cooling process. You're forcing it to boil, you're forcing it to evaporate. That's what boiling is. But you're losing energy over time, and so eventually you can freeze it. So you can boil water to make it freeze. We'll look at this when we come back from break. When we come back from break, we're going to have like a video demo day where I'm just going to show you a bunch of video demos and talk about what they mean and what you have and that sort of thing. Okay? All right. Melting and freezing. Someone from group 5, tell me what you got. Bueller, Bueller, yes.
I'm not from group 5, but do you have any tissues up there?
I have some.
I sit with someone else.
Gordon just sounds like he's going to die.
Wait.
There's some paper towels.
Gordon, zero offense to you, but I'm going to Jake.
You only have 5 groups?
You only had 4 groups, but there was 2, 4, 6, or 2, 3, 4, and 5. So there was a 5. Somebody, tell me about melting.
No offense, so we don't have to get in our turns.
Huh?
I said, please.
I know. Somebody.
Gavin was in 5.
Come on, Gavin.
It's all love, man.
I said, for melting and freezing, I said when things melt, the molecule vibrates quickly, which causes the force, like the force canceled on to the molecule, or they can't keep them together.
Okay.
So that they spread out, and then cause it turns to a solid.
Yeah. So melting is gaining energy, so gaining heat. Causes particles to gain energy. So vibrate faster like you talked about. And turn into a liquid. So you mentioned that the particles couldn't hold on to their structure anymore. That's the idea. So they heat up enough, they vibrate so much that they can't stay together anymore. And they start turning into a liquid. So that's melting. Freezing is the opposite. Freezing is just the opposite. So they lose heat, causes the particles to lose energy, and then it turns into a solid. Okay? So they start able to hold each other together because they're not vibrating as quickly. All right, regulation. So regulation is interesting. We're going to talk about regulation more later. But just to explain it, so regulation is melting, but it's melting using pressure instead of using temperature. So it causes the pressure to increase, which causes the object to melt, instead of increasing the temperature. So regulation increases pressure to cause melting. But here's the interesting thing. As soon as you get rid of the pressure, it freezes again. So the experiment I'm going to show you when we come back from break is they're going to take some fishing wire to cut all the way through a block of ice. But when it cuts all the way through the block of ice, the ice won't break. Because as soon as it melts through that layer, the layer freezes again. And so it'll cut all the way through the block of ice without actually cutting the ice in half. So we'll look at that a little bit later. But I wanted to kind of introduce that idea. All right, here's the last one. I got these ones. What do heat and energy have to do with phase changes? So when you gain heat, you gain energy. Causing temperature to rise and the phase to change. Okay, so here are your phases. So solids, liquids, and gases. Here's my elaborate drawings there. So when you gain energy, you go up the ladder. But when you lose energy, you go down the ladder. All right, lastly, how do heat pumps work? So heat pumps do work to move heat against the natural cycle. And that natural cycle is to go from hot to cold. So this is going from cold to hot. Can anyone think of a heat pump that you use on maybe a daily basis? All the time?
You said refrigerators?
Refrigerators. Yep, probably.
A microwave.
Microwaves, those are a little different because they use radiation. And they are kind of making the heat naturally. Yeah, a little bit. It's a little bit of a different situation. Yeah. So furnace is different. So furnace takes but there are heat pumps. So there are heat pump heaters, and those are a little bit different than furnaces. Furnaces set fire to gas, gets the air hot, and then pumps the air hot through the rest of the house. Heat pumps pull the cold air in, do work to make the air hot, and then push the hot air through. So it's a little bit of a different circumstance. But yes, those do exist. Refrigerators take the heat out of the cold air and then push that hot air outside the refrigerator. If you've ever put your hand behind a refrigerator, it's really hot. And the reason it's really hot is because that's where all the heat's going to. And look at that. All done. Any questions?